We introduce you now to Nicolas Bonne. Nicolas comes from the University of Portsmouth. I hope I said it right. Let me just go back to the document where I have so the title of the talk is The Tactile Universe, Accessible Astrophysics for Visual Impaired School Children. I think I met you, Nicolas. We met before. I don't remember quite where, but I'm 100% sure that we met before. Yep. And I have vivid the feeling that I had when you shared your work. So I know you're going to dazzle everyone with the important work that you're doing. So because we are already running short of time for the future presentations, I will not keep you from long. So please, Nicolas, it's really a great privilege to have you here with us. And I'll give you the floor to present your outstanding work with this group of people here.
Thank you so much for the wonderful introduction. Good evening from the south coast of England. I am talking to you from Portsmouth. I'm going to mute my camera just because I'm going to share my screen, and also my face is going to be really close to the screen so I can read everything properly, and you don't want to be looking at the side of my head while I'm talking. So I'll turn my camera off now that I've said hello, and I will share my screen if I can. Okay. Okay, there we go.
It's coming. You now need to put in presentation mode.
Yep. There we go.
It's perfect.
Okay, so I'm here to talk to you about the Tactile Universe project today. So I am a blind astronomer and science communicator. I work as a public engagement and outreach fellow at the Institute of Cosmology and Gravitation at the University of Portsmouth. Okay, so the main motivation here is that I think most of you would probably agree with me that astronomy is traditionally seen as a very, very visual science. And people with vision impairments, or people who don't see very well, can often find it very difficult to engage with topics in this subject. And so when I say visual, I mean the way that we teach astronomy, the way that we do research in astronomy, even the way that the media communicates popular topics in astronomy is really, really visual. We rely on beautiful pictures, full color images of the cosmos to sort of inspire people, to get people excited about astronomy. But what happens if you can't see those images? How do you engage with this subject? Okay. So there are a couple of things we can start doing to make a little bit of a difference and open up this subject to people with vision impairments. Okay, so one thing we want to start doing is to build science capital and the aspirations of people, or young people rather, who have a vision impairment. And if you haven't heard of the concept of science capital, it's something that's relatively new. It's being thrown around a lot in sort of public engagement circles in the UK at the moment, but it's basically the sum of a person's science-related knowledge, their attitudes to science, their experiences with science, and the resources that they have personally that relate to science. So it can be everything from whether somebody can identify themselves as a scientist, whether they find science interesting, or whether they're completely disinterested in science, or whether they spend every weekend at a science museum. So there's lots of different aspects to that. But the idea is the earlier you can get somebody excited by science, the less likely they are to be influenced by negative opinions of parents or friends, or maybe even teachers unintentionally. Okay. We also need to start thinking about developing and sharing multi-sensory resources for learning and research, and provide support and instruction for others to use these sort of without the people who've developed them necessarily. We also need to demonstrate to scientists and other science communicators how they can start to accessibilize or make more accessible what they want to communicate. And we also want to demonstrate to everybody that accessibility doesn't just help the groups that things are made accessible for. So if we make something accessible to a blind and vision impaired audience, it's going to help everybody in the long run. And so this is a really important thing to remember as well. And so our solution to this has been to create the Tactile Universe project. So Tactile Universe is a public engagement project started in 2016 using tactile representations of real data, which makes topics in astrophysics research accessible to the blind and vision impaired community. And so we do this by resource development, by creating lessons, by engaging teachers and other science communicators, and by providing positive role models who are vision impaired and scientists as well. Okay. So the basic idea that we started off with was, so as a blind person myself, I've been interested in astronomy for a really, really long time, and I always wanted to be an astronomer, but it wasn't always particularly easy for me to access the resources that I wanted to. And particularly when I did the research that got me my PhD, I had to look at a lot of images of galaxies, mostly to make sure that the data sets I was using were actually correct. They were telling me the right thing. I had a lot of trouble seeing these images though. And so when I graduated from my PhD, I started thinking about ways that I could have made my life a little bit easier using modern technology. And so we came up with the basic idea of turning a regular image from a telescope like the one on the left, which this is M51 or the Whirlpool galaxy, and turning that into a tactile model, 3D printed model that could be felt and get across exactly the same information that looking at that image would. And so the way this works is we look at all the different shades of gray and white and black that make up this image in terms of pixels. And we take the brightest pixel, or the pixel that's closest to white, and that becomes the highest point of all the tactile features that make up that image. The darkest or the blackest part of that image becomes the lowest point in that tactile sort of series of points. So you can see that in this model, the background, the black background behind the galaxy is the lowest point in this. And every other pixel in between scales between those 2 points, that highest and that lowest point. So what we end up with is almost like a topographical map of a galaxy. And by feeling that, people can get a sense of the shape of where there are areas that are brighter or dimmer, where there are areas with more stars, more gas, less gas. So there's a lot of information that can be conveyed through this tactile medium. Okay. So we started this project back in 2016 with funding from an organization called the Southeast Physics Network. We ran a 6-month pilot. Most of that pilot involved developing these models. So we made lots of versions that were different sizes, that had different heights of tactile features, so different intensities. And we basically took these to as many blind and vision impaired people in the Portsmouth community as we could find, and got their feedback on what they thought worked and what they thought didn't. And all of this ended in a big public event that we ran in early 2017, where we tested out all the ideas we'd had for getting this information about galaxies across to people with poor vision or no vision. And in general, I think the project wouldn't be anywhere near as successful as it is without the help of all of the blind and vision impaired people who've given us their opinions, their feedback, and their ideas. The models have improved a lot as a result. There's lots of features built into the models that wouldn't be there at all if we hadn't spoken to other people, if we'd just gone with my original idea. And I think that speaks to the diversity of people in general, but also the audience that we're trying to develop this stuff for. So everybody with a vision impairment is going to be slightly different in how they want to learn, how they deal with their vision impairment, what kinds of ways they have come up with themselves for working around their lack of vision. And so by talking to as many people as we could, we were able to develop really, really versatile models. And so these are the final versions of the models that we've created. You can see they look a little bit neater than that first example. We've also got large full color images that we can use for people who have a little bit of vision but also want to touch the models. On the right hand side here, this shows the back and the front of an example of one of our models. And you can see that we've actually got the original picture that was used. So the actual telescope image, the real data that was used to make this tactile model. And we've attached that to the back so that if people want to, they can look at one side, they can look at the image and they can touch the tactile features on the other. And so they can enhance their experience if that's what they want to do. So these models give people a lot of different options. Okay. So like I said at the start, to really make a difference, we want to engage vision impaired people when they're relatively young. So when they're in their last couple of years of primary school or their first few years of high school. And like I said, the reason we want to do this is because we want to show them that science is accessible, that they can do astronomy if they want to, before anyone else tells them that they can't, and that opinion gets embedded in their way of thinking. So with additional funding from the Science and Technologies Facilities Council, we were able to go out to schools and develop these resources a little bit more. So we chose a really good selection of galaxy images that allowed us to basically tell the story of how galaxies evolve, how they can change over time, and the kinds of physics that goes on inside these galaxies or around these galaxies to make them change shape. We're also able to create workshops that integrated all of this information, so things that teachers could actually run for their students in their classrooms. We also put together a lot of supporting documentation, so things like lesson plans for teachers to read, things like full scripts for people who don't feel so confident talking about astronomy, but also other things like best practice guides, so for people who aren't used to talking about science to people with vision impairments, to make them feel more confident with that idea. And here I've got two pictures of us talking to the school students that we did all of our testing with. So on the left is my colleague Jen, and she's describing one of the tactile models to a totally blind student from the school that we did our testing with. On the right-hand side, I think I'm talking about something going on inside one of the galaxy models with three of the other students that we worked with. Okay. Along the way, obviously the thing we've made is very simple. Our models are quite a simple idea, but they have a lot of applications. A lot of people have approached us and asked us to make specific models for the projects that they're working on. So images of things like the image of the black hole in M87 that came out last year, or things like images of comets or images of the cosmic microwave background. So we've collaborated with a lot of other groups. Some of them have been museums or for things like exhibitions. We've also worked internationally with other groups who are developing resources for blind and vision impaired people to help them learn about astronomy. We've worked with iData in America. We've worked with a group called AstroBVI in South America, who've taken our resources and built their own kits, done training, got those resources out to lots and lots of people. And I've also worked with another astronomer to produce a science show at the British Science Festival. We've also had a lot of invited talks that we've gone to talk about how everybody can start making astronomy and the way they present astronomy a little bit more accessible. So here I've got a picture of one of the models we helped a museum make. So this is a tactile image of the Milky Way edge-on as viewed by the Gaia satellite. This is 1.7 meters by 0.4 meters, so it's quite large. But you can imagine just the amount of detail in that model. If somebody's to run their hands over it, they would get a really good sense of the structure and the shape and all of that detail in the Milky Way. Here I've got two pictures of workshops and talks we've done. So on the left is a workshop we ran at the last CAP conference in Japan. So communicating astronomy to the public. We talked here about the kinds of language people can start to use to communicate really visual ideas in less visual ways. And we used our models as an example. On the right-hand side is a really fun talk that I've put together, which uses really I guess bad examples, all the mistakes that people make when they put presentations together but make them really, really inaccessible. So I've deliberately made this title slide really, really inaccessible just to get a point across. So that's a fun talk that I give sometimes. Okay, and so as a result of all of this, obviously, so working at Portsmouth, there are only 3 or 4 of us. There's my colleague who makes our models and works on our code. There's my colleague who is an expert on public engagement and outreach, so she advises on a lot of that. And then there's myself, and then there's our science advisor as well. So only 4 of us. And our goal really is to get these resources out to as many people as possible, particularly in the UK. So to do this, we had to start looking at, I guess, recruiting other people. So it couldn't just be us doing all of this delivery. We had to start thinking about getting other people around the country involved and invested in the project. So in 2019, again, with that funding from the SDFC, we ran 5 presenter training workshops in locations all across England and in Scotland. And those were attended by 66 science communicators in total. And during those workshops, we stepped through all of the different lessons we'd put together using our resources. So everything covering the solar system to galaxies. And we also talked a fair bit about how people could feel more comfortable with the idea of communicating something so visual to people with a vision impairment. Because a lot of the feedback we were getting was that people, they felt uncomfortable. They were worried they were going to say something insulting. They were worried that they weren't going to be able to explain something to somebody who couldn't see. So a lot of it was us making people feel a bit more confident about that type of thing. So after we'd run those workshops, we made all the resources for and then distributed 20 resource kits that contained everything from lesson plans to our galaxy models to tubs of Play-Doh and CDs to make model galaxies for people to feel. So all the resources anybody would need to run our workshops. And we gave those to 20 groups of people who were trainees who turned up to these workshops that we ran. And so the idea is that now they're going to take those resources to engage the local student vision impaired community in their parts of the country. And we've also made our tactile resources, along with all of our documentation and best practice guides, printing guides, everything like that, available online for free as well. So we want anybody anywhere in the world who wants to use these resources or use the code that we use to make these resources, we want them to be able to access that and to use those resources as freely as they can. So all you need is a 3D printer. Okay.
I'm afraid we're reaching the end of the time.
Okay. Do I have 2 minutes? Yep. Okay. So this is just a picture from one of our workshops. So you can see everyone here is really invested. We have a couple of vision impaired people in attendance here because they were interested. They wanted to learn how to teach this stuff to other vision impaired people. But you can see there's just a lot of stuff going on here. On the left is a picture of 160 of the galaxies we made to send out to people. On the right-hand side is an image of all the boxes containing the resources. They're loading into a van, getting ready to drive those out to the people who are going to receive them in the UK. Okay, so just really quickly. Obviously, we want to make sure that we can support this network of people delivering our resources around the UK. So our plan moving forwards is that we're going to hold virtual meetings and drop-in sessions so that if anyone's ever having issues, if they're having trouble contacting their local community, they can get in touch with us. They can also share their experiences and help each other by talking about what's worked and what hasn't worked. We also are putting together a shared evaluation framework. So we want everyone to collect the same evaluation data so that we can compile all of that and put together a really detailed case study on how well all of this has worked and where we've encountered problems. We also want to use that to improve the project moving on. And we also want to develop things like shared FAQs and best practice guides that anyone can edit and add to based on their experiences delivering this project. Okay. And next, we're going to start developing stuff for slightly older students. We want to look at making resources to do with gravitational waves. And so we're going to do the same basic thing. We're going to develop those resources. We're going to test them and get feedback from the local vision impaired community. Then we're going to go out to the LIGO, or gravitational wave research centers around the UK. We're going to train up the researchers and scientists so that they can deliver our resources themselves. And that will in turn expand the number of people in the country who are using our resources, the number of blind and vision impaired students that we're reaching. And just finally, if you wanted to read more about the project or get in touch with us or download the resources, all of the links for that are listed here. So thank you so much for letting me speak this evening.
Well, I am speechless. To be honest, I again, very impressed with your work. And although we don't have time for questions right now because the time is passing, yep. But I have to say that we will contact you for sure to have a more in-depth, with time, workshop for educators, of course, if you agree with that, because I think this is such an important and outstanding work that you guys are doing. Congratulations.
Thank you
for
very
all
much.
This work and for this magnificent presentation. Nicolas, it was a true privilege to have you with us. Thank you very much.
Thank you very much. And it'll be my pleasure to help in any way that I can.
Yeah, everybody heard it, huh? You said it publicly, so now there's no turning back.
Well, this is my job, so yep.
We will be contacting you. Thank you so much.
Thank you very much.
Okay, I'm sorry guys that I have to rush everyone.